Hi, everybody. Welcome to today's webinar. My name is Emily Spranger. I'm an academic trainer for the Center for Teaching and Learning. This is our second stats webinar with one of our very own academic coaches, Rachel Brunn. Today, we'll be covering basics of hypothesis testing. Just a couple of housekeeping things. As a reminder, this webinar is being recorded and we will post it in our CTL LibGuides page for future reference. There was a stats handout that went with this webinar. I will post it in the chat once I'm done with my introduction here. And I did send a couple of emails out to people who registered for the event before Sunday. So in case there are any last minute registration folks in our attendees today, I will post that PDF in the chat for you. Please do have conversation in the chat, ask questions in the Q&A. If you do have a question that you want Rachel to be able to cover today, please post that in the Q&A just because I don't want it to get lost in the chat. I'm going to pass it over to Rachel Brunn.
I am very excited to talk to you a little bit more about some quantitative analysis stuff. You may have attended another webinar I did about stats basics. So I thought talking about hypothesis testing and some of the concepts revolving around this process might be a good way to build off of some of those concepts that I talked about before. So my goal is to get through the steps of hypothesis testing briefly, but enough that you kind of understand them. I want to make sure that I'm not going too in depth. So if you have questions, like Emily said, post them in the chat. I will be getting to those at the end. For those of you that did have the handout, either printed off or downloaded beforehand, if you didn't already give a try to answering some of those questions to kind of test what you already know, I encourage you to work on filling that out and answering those questions as we go. I will be addressing them indirectly as I'm talking. So listen for those answers as they're in the presentation. And then at the end, if there were any that you missed or you felt weren't clear, let us know and I would be happy to kind of loop back and clarify those for you. All right. So as I stated, we're going to talk about hypothesis testing as a process. So there's a few steps to hypothesis testing, and this is only in quantitative research. So if you're doing a qualitative study, you actually don't test hypotheses. You don't even have hypotheses at all. So if you're only thinking about doing qualitative research, this might be informative, but maybe not applicable to your own personal study, but it could also be applicable to some of your coursework that you do leading up to your study. This guide is not going to be all-inclusive. So hypothesis testing is somewhat individualized to the test that you're conducting. So what test you're using to test to see if your hypothesis is correct or not. But I'm not going to get into those specifics. So if you're working with a specific test, then I would encourage you to reach out to the Academic Success Center for some individualized support in the area that you're looking at. Today, I'm just going to talk on a very basic introductory level. So the first step in hypothesis testing is to state the null and alternative hypotheses. Now, most of us probably learned about hypotheses in like middle school when we were learning in science class about like the scientific method. And we were only taught about one hypothesis, and that was your prediction or your educated guess about what the results were going to be. So when we're talking in research about a null and an alternative hypothesis, take that definition of a hypothesis that you already feel kind of familiar with and apply that to an alternative hypothesis. The alternative would be like the claim that you're testing or what you predict your data is going to show. The null hypothesis, there's a few ways to think of it. Some describe it as being the opposite of the alternative. I think of it as being like the status quo, or basically saying that whatever you're predicting to happen isn't going to happen. It's like the negative Nelly. So the null hypothesis is kind of a statement of no significance. There's no significant relationship. There's no significant difference. There is no significant effect. Those sorts of things. So when we're seeing the null hypothesis, think of that no word. The alternative is your claim. And this could be something as basic as there is a relationship, there is a difference, there is an effect. Or it could be more specific, like there's a positive relationship. This group is larger than this group, things like that. So it could be specific or it could be general. And I'm going to touch on that in just a little bit when I talk about like alpha and one-tail versus two-tailed tests. So first step, we're stating our null and alternative hypotheses. Once we've stated those, we have to determine what our level of significance is going to be. In research, we call this alpha. And basically, this is going to represent how willing we are to find the wrong answer. It's a general way to put this. So you'll learn about this term called a type 1 error. And alpha represents your chance of making a type 1 error. A type 1 error being you find significant results when in reality, so if you're collecting data, you collect data from a sample and you're extrapolating the results from that sample to the population. So when I say in reality, I'm talking about the population. So your sample says, hey, there's significance here. When in reality, the population shows that there's no significance. So if your study finds significance when the population says there's no significance, you have made a type 1 error. We want to keep the chance of this happening being very small. Typically, at the research level, we don't want this value to exceed 0.05, which you can think of as 5%. So there's a 5% chance that I would find significant results when they don't actually exist. Something interesting to note here is that when you're running a research study, you may have multiple hypotheses. Every single test that you conduct to test those hypotheses has an alpha level. You want the overall alpha of your study to not exceed 0.05, which means if you're conducting multiple tests, you may have to lower the significance for each test to ensure that the overall alpha of your study remains at 0.05 or lower. And I'll give you for instance. So if we had a bunch of tests and we just kept testing on our sample, just trying to find something, statistically speaking, we're going to get significance just because we've analyzed so much. Like we're going to happen upon something significant, which may not actually be anything meaningful at all. So we can't just run as many tests as we want. We want to try to run as few as we can in order to test our hypotheses. Typically, it's one test per hypothesis. And again, we want to make sure that we have just a few hypotheses for our sample data to ensure that we're keeping that alpha level of our study low and reasonable. So we're not finding significance that isn't there. Step 3 is to state the decision rule. So the decision rule is, under what circumstances are you going to reject the null hypothesis? When we're conducting research, our decision is always about the null hypothesis. Are we going to reject the null hypothesis? Or do we fail to reject the null hypothesis? Basically, does our data support the null hypothesis, or does it refute the null hypothesis? There's a couple different ways that you can think about this decision rule. One is the traditional method. Now, some of your courses might teach this way, where you're comparing a test statistic to a critical value. Most of the time, especially at this level, you're running these tests using something like SPSS or Excel, and the test gives you a p-value. And so you're not actually going to use the traditional method. You're going to use the p-value approach. So what you're going to determine is if the probability associated with the test statistic is less than that significance level that you determined in step 2. So I told you I was going to talk about one tail, two tail, and that's where this comes into play. So when we have a one-tailed test, we're making a directional prediction. So you can see here, like where they're talking about mean is greater than or mean is less than. I like these. Unfortunately, you guys learn to write these in sentences. And I'll tell you what this sounds like in a sentence. But I really love when they're written in notation because all you have to do is look at it. If it's pointing, you're looking at the tail that it's pointing to. It's like super simple. But in words, this is making a specific prediction like the sample is greater than the other sample, or the medication significantly reduces blood pressure, things like that. So I'm using directional words, greater than, less than, more, things like that, versus a two-tailed test. Now, think of a two-tailed test as like, I don't know how they're going to be different, but I think they're going to be different. That's kind of what a two-tailed test is. You're not discounting one tail or the other. So maybe you're just thinking that there's a relationship between the variables. You don't really know exactly what that relationship is going to look like, but you're pretty sure that there is going to be a relationship there. So you would do a two-tailed test. So that way, whether it's a positive relationship or a negative relationship, you'll capture that significance. Versus if you limit yourself to a one-tailed test and you predicted the wrong direction, then you're completely missing the other tail. There's definitely pros and cons to each approach. I'm not going to get into those, but I do want you to have a general understanding of what it means to be a one-tailed test versus a two-tailed test. And tying this into this decision rule, when we're thinking about this probability and alpha, alpha would be this area in red. And the p-value is the probability associated with the test statistic. We need that p-value to be in the red. And you can see looking at these shapes, as I move to the right in this tail or the left in this tail, that area is getting smaller. And remember how I talked about alpha being 0.05 or 5%? This red is 5% of the entire curve. And if it's getting smaller as I move farther into the tail, that means that my p-value, my probability, also needs to be smaller so that it falls into the tail. So I need a probability of, say, 3% or 4%. Anything that's less than 5% would get me into that tail, regardless of which tail I'm looking at. So if that's the case, if my p-value falls into this tail, then I would be able to reject my null hypothesis. That means that the data is significant. It supports my alternative hypothesis, which leads into step 4. So step 4 is actually calculating your test statistic, or in SPSS terms, plug in the data and run the test. So again, this is very specific to what test you're conducting. So for example, if you're doing like an ANOVA, you would get an F ratio. A t-test is going to give you a t-score. If you're running a correlation, you're going to get Pearson's R or Spearman's Rho, things like that. So each test has its own test statistic. But aside from that difference, the way that we interpret that is all the same. The test statistic is just a value. And when we're given, when we're given our p-value approach, we always report that test statistic in our results. So in our findings, our summary of what we found. But we don't really pay as much attention to it because it doesn't necessarily have meaning. If you haven't learned that traditional approach, that test statistic is just a number to you, and that's totally okay. What's really important is that you understand that you need to find the associated probability, and I put that in quotes because it's going to show up in your stats assignment. And I promise you're probably going to be like, what's the associated probability? How do I find that? It happens. Associated probability is just asking for the p-value, which SPSS doesn't like to call a p-value. It likes to be super confusing, and it calls it significance, and it abbreviates it SIG, which, you know, when I was talking about alpha being your level of significance, and then SPSS comes out and they're like, oh, here's your p-value. We're going to call it significance. It gets really confusing because it's like, okay, well, what's my significance? Just remember, significance in SPSS is your p-value. You're going to compare that to that alpha value that you decided on for your test, and you're going to use that to determine if it's significant. And all of that comes here when we calculate our test statistic or run that test using SPSS or Excel or whatever tool you're using. Once we have run our test and we have our test statistic, then we have to state the decision regarding the null hypothesis. So think back to step 3 when we were talking about the decision rule, and we were talking about the situation or the circumstances in which we would reject or fail to reject the null hypothesis. Step 5, now that we've actually collected our data and analyzed it, now we get to make that decision. So we have 2 choices. We can reject the null hypothesis. That means we're going to wad it up, throw it out the window. Our data says that's not the right one. A technical way of stating this is that there is sufficient evidence to suggest your alternative hypothesis is true. Now, in statistics, when we're stating these conclusions, things are not black and white. We're not proving our alternative hypothesis. We're not disproving the null hypothesis. We're not rejecting the alternative. We're not doing things like that. All we're doing is saying what the evidence supports. And if you think back to what I was talking about with that type 1 error, there's always a chance that your conclusion is wrong, always. So you don't want to speak your conclusion in definitive terms because you could be wrong. So we indicate that there's some support for the alternative or there's not enough support for the alternative. So we can fail to reject the null hypothesis. That means that we didn't have enough evidence to throw it out the window. We failed to reject it. And I know that's like a double negative, which can be kind of confusing. Failing to reject the null hypothesis simply means that it's not significant. So there was not evidence to indicate that the prediction that I made was correct. And I kind of put our clues in here relating back to that p-value approach to the decision rule. We reject the null hypothesis, we throw it out. When our p-value or that associated probability is less than alpha, and we fail to reject the null hypothesis when that p-value is greater than alpha. And then the last step is to state our conclusions in layman's terms. What that means is we now need to step away from the statistics and talk to normal people, which from all the students that I connect with, I feel like that's like everybody. So many students are like, math isn't my thing, statistics isn't my thing. Great, you're gonna love this part because this is where you're talking to everybody that is not a statistics guru. You need to tell them what your results said. So it's great if you can be like, oh, we're gonna reject the null. Okay, what does that mean? So this is the part where it's really specific to whatever you're testing. So let's use an example. Let's say that I was looking to see if there is a difference in height based on gender. And we're just going to be very simple and basic, and I'm just going to say male and female for gender for simplicity reasons. So we're comparing the height of a bunch of males, the height of a bunch of females, and we're going to see if those are different or not. So let's say I find significant results. So I reject the null hypothesis. In layman's terms, what that means is that there's evidence to suggest that there is a difference in height based on gender. And assuming my general understanding of how height works, it probably shows that males are significantly taller than females. And I would know that because I could look at the means for each group. And if the male average was higher than the female average, and I find significance, then that means that it's significantly higher. So males are significantly taller. So I'm taking that rejection and taking it back to that hypothesis that I made And I'm stating the conclusion using the variables that I was interested in and kind of breaking it down and explaining exactly what I saw. And for some tests, like a t-test, it's as simple as what I just said. Something along the lines of saying that there is a difference and that this group is greater than or less than this group. With other tests, like an ANOVA or a two-way ANOVA, this interpretation could be a little more complex. It's not just a simple direct answer. You know, with a two-way ANOVA, you've got two main effects and an interaction effect that you're looking at. So you could have multiple statements of your conclusion here. But the biggest piece is that you are able to pull that back to the variables that you were researching, tying into kind of the hypotheses that you stated, and including those variables when you're talking about the results of your test. So I think I breezed that a lot faster than I gave myself credit for. So I do have plenty of time for questions. Before I open that up, Emily, I am going to, let me close out of this. I want to open the handout answers because I know you guys asked for this. So let me.
Thank you.
Let me see. This out
And while you're pulling that up, I did have some questions about where the webinar is located, just so everyone knows, all of our attendees. Every single webinar that we do through the CTL is recorded and we post it on our CTL LibGuides page. Right underneath the webinar section, you can find them all there. We also have a YouTube channel as well too through the CTL. And we post all of our public webinars through there as well too. So like and subscribe. That's my plug. Shameless,
Okay.
but do it.
Hopefully you guys can see this, okay?
Okay, let's see. So the screen that I see, Rachel, can you describe to me the screen that you are, oh, there we are.
I say I should have just switched.
Yes, it
I
did.
have my other screen up, so I have light on one side.
Great.
Okay, so it should be showing the answers for that handout now.
Could you potentially switch it to just the one so that it's not double-sided, so it's a little bit bigger, if that makes sense?
Yeah, I just figured if I had both up, then everybody could see all of the answers at once.
It might be a tiny bit tiny for the text, potentially.
Yeah.
Oh, the Zoom. Thank you.
Yeah, I was gonna say it's not doing what I want. I also have to move everything around every time that I'm trying to click on everything. Okay, does that work? Is that big enough or should I make it bigger?
If you could zoom in just a tad bit more, that would be great.
Change. Why is it not letting me do my Zoom percentage?
What if you do the percentage right down there?
Let's see. Page. Let's try that. There we go.
Oh, thank you. That's perfect.
All right, so I'll just kind of slowly scroll through them. If you want to start pulling up questions.
Absolutely. Let me see. A couple of questions. So while people, yes, take your time as you scroll through this. So the very first question is from Rob. And this question popped in there in the very beginning of your webinar. So keep that in mind for context. So you would do this at the outset of a study to determine whether one has a valid interrogation or as a controlling method for reporting results. Question.
So you wouldn't have results to report if you didn't do a hypothesis test. So you would go through this process in order to get to results. So if you're already at results, you've already done some hypothesis testing.
Okay, thank you. And this question is from Lee. So the alternative hypothesis is the same as the hypothesis we were taught when we were younger, question mark.
Yes, yes,
Great.
Because the hypothesis that you were taught in terms of like the scientific method is your educated guess. And when we're doing research, you spend hours upon hours upon hours doing literature reviews, so looking at research related to your topic of interest, and you're looking to see what other researchers have found as they've been studying that topic. And based off of your literature and your either theoretical or conceptual framework that you're using, which basically is kind of like the reasoning behind why you predict what's going to happen. I have a psychology background, so an easy example that I could give of this is like learning behaviors. If I wanted to talk about how kids learn how to behave, I could apply like an operant conditioning approach to that. So talking about how reinforcement affects their behavior. So that framework would explain why I predict a specific outcome in my hypothesis. So you're using all of that background research to develop your hypothesis, which is your prediction, because you've done all the research and you're not just randomly guessing, you're making an educated guess, which we call the alternative hypothesis.
Thank you, Rachel. Question from Lee. I would also like to know how you would ensure validity of your study. Would you take the potential threats to validity and call that out specifically, or how your study covers each threat to ensure that your study is valid?
So that's actually completely out of scope of hypothesis testing. But it really depends on what measures of validity you're going to bring in to support your study. I mean, you could go super basic with face validity and say that my study is valid because it appears to measure what I say it's measuring. But there are also statistical methods of testing validity as well. And typically, depending on what your constructs are that you're measuring, a lot of times it's better to use established assessment tools that already have established reliability and validity to them. In your study, you would reassess those pieces to ensure that your study had the same reliability and validity. But typically, if you're creating your own, it's in a perfect world, you would be doing a pilot study to test the validity of your assessment tool before using it. Which obviously takes more time. It means more participants and all of that crazy chaos. So I don't talk too much about validity here. It's definitely a valid concern and a valid question. As far as assessing the validity of your study, though, it's really going to be dependent on the type of validity that you're wanting to use. And I would encourage you to work with one of our statistics coach in the Academic Success Center if you need some help with validity for your research.
Awesome. Thank you, Rachel. I see some questions in the chat. We'll get to that very shortly. Don't forget, if you have questions, you can pop them in the Q&A. There's one more in the Q&A that I want to ask before we move over to the chat. Must you always have a null hypothesis?
It's always implied. Like
Okay.
I said, the hypothesis is your prediction. The null is, it's always there. For whatever reason in academic research, so like when you're working on a master's thesis or your doctoral dissertation, they want you to state these directly. But when you're reading like a research article, they don't come out and state it. In fact, you're lucky if they even come out and directly state their hypothesis. So when you're looking at like applied things as opposed to the academic setting, things are a little different. But the null hypothesis is always there, and it's always what is being tested in a sense to determine if you're going to reject or fail to reject it. But because what we're really interested in is the alternative, most of the time when you're reading articles and research and things like that, what's focused on is that alternative hypothesis. And they don't really elaborate if they just say that there was no significance. They don't state that that means that there was no difference, right? They don't really get into that. So you don't have to make a null. It's always going to be there. It's the implied hypothesis based on your stated hypothesis.
Thank you, Rachel. Couple more questions that I can see here. Once the data is collected, is there a way to determine which test should be run on the data to perform analysis?
Well, ideally, you already know what tests you want to run before you collected that data. So like when you're doing your dissertation, for example, when you're working on your proposal, before you've submitted it to the IRB, meaning you can't collect data from people yet because the IRB hasn't approved it, you should have already discussed in your proposal what your anticipated statistical analysis method was going to be. So you already have your purpose of your study, your problem statement, your research questions, your hypotheses. All of those things are going to lend towards what statistical test you conduct. The catch to this would be, let's say I was going to do like a correlation. So I'm going to measure relationships. I would know this because my hypothesis would indicate that there is or is not a relationship between some variables. That tells me I'm going to be doing a correlation analysis of some kind. There's lots of them. I would have to look at things like the levels of measurement of my variables, the number of variables that I have, things like that, to determine which test to do. And then once I collect all my data, every single statistical test has a number of assumptions. Think of assumptions as like prerequisites. So in order for you to be able to do that test, these prerequisites have to be in place first. Some things like normality, for example, which means that normal distribution. So if my data does not meet that assumption, I can't do that test. So you could choose a test and then collect your data and then go to test those assumptions and then find out maybe some of those assumptions were violated. And then you may have to switch to a different test, and it's totally okay. Happens like all the time. Basically, what you would end up doing is just saying something along the lines of these assumptions weren't met. Since these assumptions were violated, we go with this test instead. It's totally okay. Nobody would get upset about it. Doesn't mean your results aren't valid. Doesn't mean you don't have meaning to your results. Nothing of the sort. Just means that you couldn't do the test that you ideally wanted to do. But you should know all of that before you even start collecting your data, because you need to know how that data is going to be used in order to make sure you're collecting the right data.
Okay, thank you so much, Rachel. I'm going to have, I know I said I was going to get to the chat, but there's one more question in the Q&A that I want to get to before we go to the chat, because there are some specific questions about the sheet in the chat. So
okay.
It says, hello, why don't we use the term except when we are referring to the null hypothesis? If you fail to reject it, is that not the same thing as inferring acceptance?
Nope.
Okay.
Nope. So accepting means that you're saying that the null hypothesis is true. So I didn't talk about this because it doesn't necessarily come into play when we're talking about the process of hypothesis testing. So I talked about a type 1 error. It has a partner. It's called a type 2 error. Somebody was like super creative when they named these, right? And type 2 error is related to the power of your study. The power being the ability of your study to detect a significant result if one exists. So like with the type 1 error, where I can find significance when it doesn't actually exist. A type 2 error means that I could miss significance that actually exists. So I find no significance when in fact there should be significance in my results, which is probably worse than finding significance when there isn't any. But in either case, there's always this chance, whether it's a type 1 or a type 2, there's always a chance that the conclusion of your study is wrong. So we don't speak in terms of matters of fact. We support one position or the other. So if we're failing to reject the null, that doesn't mean that I'm accepting that the null is true. It just means the data that I collected doesn't support the alternative. The data that I collected supports the null hypothesis. Somebody else could collect data from different people the same way that I did and come up with a completely different result. So we don't accept it. We just say that it is or isn't supported by the data that we collected in our particular study.
Thank you, Rachel. Couple of things. I'm going to get to the chat. Someone was wondering if you could scroll back up to the answer for 3 one more time.
Yeah, I actually just went up and
Oh, whoopsies.
restarted my
Oh,
scroll. No, you're
right
good.
there. Oh, thank you. And then if time permits, can you explain how you arrived at the answer for number 4?
Yeah.
Okay.
Okay. So when we're talking about the decision about the null hypothesis, so our probability, so this is that associated probability that I was talking about, that p-value, was 0.03. So what this means, the probability of obtaining the test statistic value that I did, if the null hypothesis was true, and to put this into like relatable terms, let's say I was looking for differences. So this p-value is the probability of obtaining the t-score that I got if my groups are the same, so not different. So if my p is 3, that means there's a 3% chance that I would get the t-score that I did if the groups are the same, which 3% is not a very big chance, which indicates that it would be very unusual, not impossible, see, just unusual for me to obtain that value, which kind of indicates, doesn't prove, indicates that those two groups are different from each other. Because if they were the same, then it would have been far more likely that I got the result that I did. The fact that the result that I got was very improbable, being only a 3% chance, indicates that they're probably different from each other. So when we're talking about the decision rule, we talk about that p-value being less than the alpha value, indicating significance. So here, my p-value is 0.03, and I compare that to alpha of 0.1. 0.03 is less than 0.1, which means it's significant. When our results are significant, we reject the null hypothesis. The data supports the alternative hypothesis. Same thing for B. 0.03 is less than 0.05, which means it's significant, so I can reject the null. The data supports the alternative hypothesis. And then on part C, 0.03 is greater than 0.01. So in this case, if my alpha, so if I had set my level of significance to 0.01 or 1%, then even with a p-value of 0.03, which is actually pretty good, I would fail to reject, which means with this significance level, my data, the exact same data that would have rejected these two, would fail to reject. My data supports the null hypothesis under this level. And remember, because you're probably thinking, well, why would you choose something that small? It's all about that chance of a type 1 error. And while something like 0.1 for alpha could be used theoretically while studying statistics, at a research level, we typically won't accept anything that's greater than 0.05. 0.01 is even more stringent than that, but that means there's only a 1% chance that you find significance that does not exist. So basically, if you find significance, there's a really, really, really good chance that that significance actually exists, right? So if you want to have more strength in your results, you would set a smaller alpha like 0.01. But you could end up with something like this where you get a probability that's greater than that, that would, on other circumstances, be sufficient to reject the null. So hopefully that helps.
Thank you so much. I know we just went over 4, but would you mind just starting your scroll from the top of the page one more time? And then we'll kind of go down as we address more questions here. Okay. Question here. Which is better to study, quantitative or qualitative?
I think it depends on the question that you're asking.
Yeah.
And I find it interesting. I strongly prefer qualitative research because to me, it makes so much more sense and it's easier. However, many people that are in the qualitative field actually feel the opposite. And so think of it this way, like people that have kind of like an analytic, mathematical, computational sort of thinking process would probably prefer quantitative research. Whereas people that are more into like writing and, I don't want to say less conceptualizing, but maybe conceptualizing in a different way, prefer qualitative. There is like this happy middle called mixed methods where you can do quantitative and qualitative together. And if we're being honest, I think that that's actually the perfect world right there, because there are limitations to qualitative research. Qualitative research is like a deep dive. So this is, maybe you want to understand better what sort of emotions teachers experience as a result of administrative changes that impact them that aren't in line with their beliefs. So you may do like an open-ended survey or an interview with teachers and just kind of get them to talk about how they feel about things, how they've been impacted by decisions, things like that, which is all great, but you can't really do more than just say, okay, this is how teachers are feeling. Versus quantitative research, you can go so far as to say, well, this causes this to happen, which is great. But then sometimes we have this underlying question of, okay, like, well, why does that happen? You can't answer that with quantitative research. You need qualitative research to answer that. So this is why I think mixed methods is, you know, like a perfect little middle world, because you can build both. You could, you know, determine, does this cause this? And if so, why? And that why is answered through your qualitative questions. But if you can imagine, if you're doing a mixed method study, in essence, you're doing like 2 studies at the same time. It's a lot of work. So most people don't do it. Most people don't recommend it, you know, for your dissertation. You definitely can do it. But as far as which one's better or which one you should do, it is completely up to you. My recommendation is to look at research in both fields. And as you're reading through their studies and stuff, which one's more interesting to you? Which one do you understand better? Which one's more relatable to you? And then as you start thinking about your research idea, what types of questions are you asking about it? What do you want to know? If you find that those questions tend to be more quantitative, then look at quantitative research. If those questions tend to be more qualitative, look at qualitative research. There's no worse or better. It really just depends on what you're interested in studying and what questions you're trying to answer.
Thank you, Rachel. Can you briefly discuss how the population, number of participants, or normality of distribution may affect test statistics, such as how this may affect the use of Wilcoxon versus the t-test for this?
Okay, so the population, in most cases, for most random variables, is going to be normally distributed. Now your sample data may not necessarily be. So I don't know, I feel like there's a lot going on in this question. There's multiple questions here.
There's. Do you need me to say it again?
The first part.
Okay. Can you briefly discuss how the population, number of participants, or normality of distribution may affect test statistics?
So the population isn't really going to affect your test statistics because your test statistics are based on your samples. The number of participants absolutely can. In fact, if you have fewer than like 30 participants, you probably don't have enough participants to really draw meaningful results. Not saying you can't draw any. It's just saying that if you have a really small sample size, your results probably won't move past the sample that you were studying. And if you do like a power analysis, when I was talking about power, you'll probably find that the power of your study is not very strong. So those smaller sample sizes could definitely influence your results. As far as influencing your statistics that you conduct, yes and no. The smaller your sample size, if you're doing continuous variables, for example, the harder it is for you to achieve normality on those variables. So the more likely you would have to do a non-parametric equivalent for your data. So your sample size absolutely could influence things like that. This is why before you collect any of your data, once you've decided what tests you're doing, things like that, you would do what we call an a priori power analysis. And I'm not going to go into detail. Basically, you plug in a bunch of numbers and it tells you the minimum number of participants you would need in order to achieve the values that you plugged in. So it's taking into consideration what power level you want and things like that. So you would do that first to help you get an idea of how many people you need in your study to have a chance at having meaningful results. And then there's this whole other world of thinking that's talking about the proportion of your sample to the proportion of the population and how well you could generalize the results from your sample to the population based on how representative it is of that population, which again would have nothing to do with your statistical test that you're conducting and more about how you could generalize the results of your study.
Thank you, Rachel. And I'm just gonna ask this question for selfish reasons because I just started my doctorate. Is there software to do the math?
Yes.
Okay.
Once if you're in your EDR courses, you'll take some statistics courses that rely on SPSS. Some of our other programs, I believe, like our master's program, the students in those statistics courses usually use Excel. I believe it's our business program. One of them has students using another program similar a little bit to SPSS, and it's called R, or R Studio, or R Programming. I've seen it called lots of things. R is how I usually refer to it.
Okay.
It is not my favorite. I've dabbled in it a little bit and ultimately decided it wasn't worth teaching myself if I could just use SPSS.
Okay.
If you were a computer programmer, you'll love R because it's coding language. You tell it, you give it code to generate what you want, which is great because you can customize things and stuff like that. If you are not a computer programmer, you'll be happy with SPSS because you just click stuff.
Oh my
and
goodness.
all of that, R is available free to everybody. SPSS is free to students through NCU. The G Power I was talking about is free to everybody. If you're doing qualitative research, NCU makes In Vivo free to students. So you do have some analysis tools available to you at no cost for being a student with NCU.
Awesome. The G Power, is that what you mentioned?
Yes.
Is that the same as G plus fall underneath that, or is that a separate?
That's something different.
Okay, cool. We have some time for a few more questions, and I appreciate everybody asking all of these questions. This is so great. Does the research loss significance? Oh, excuse me, I read that wrong. Does the research lose significance if not testing the null hypothesis?
Well, no, it's not going to lose any significance. But you can't test it without testing the null. So all of the decisions that you're making are about the null hypothesis. And I know, like I said, that gets a little confuddled when we're looking at research because they don't talk about a null hypothesis at all. Really, we only see these terms when we're looking at, like I said, like theses and dissertations, because the null is implied. What we're most familiar with is things like significant or not significant. So anytime that you see research that says that the results were not significant, what they're saying is that they failed to reject the null hypothesis. So we're always testing the null hypothesis. And so you don't lose significance if you don't test it, but technically you can't not test it. It's always there.
Thank you, Rachel. How do I avoid bias? For instance, how can I ensure that calculated results are not massaged to answer the question that I'm looking for?
That is a really great question. And you can't. So it really relies on you, the researcher, to present your results in an unbiased fashion. And I'm not going to say that there's not research out there, even peer-reviewed published research, where maybe they removed data, maybe they ran their analysis and it seemed to be going okay, but there were some values that threw off the results and they removed those values and they were able to achieve significance once they removed those values. You wouldn't know that. They would have to disclose that values were removed, but they could provide justification about them just being outliers or things like that. And so anytime that you're looking at statistics, you don't want to just take those statistical results at face value. In fact, it can be really deceptive if you only see part of the results. Like if you're given like a mean, but you're not given a standard deviation. You have an idea of that average, but not much about the variability, and that variability says a lot. So you always kind of want to take statistical values with a grain of salt. It's always better if you can evaluate more thoroughly. So rather than just looking at a summary of some study that was done, go read that study and get a better idea, because there's going to be more information there, not saying that it's not still subject to potential bias, but you have more information available to you. So you may have seen, oh, well, this is significant. Wow, that's really crazy. And then you read the article and it's like, okay, well, it's significant, but it has like a pretty much non-existent effect size. So yeah, there is significance, but it doesn't really mean anything. So there's a lot that goes into statistics. It is really easy to present what appears to be clean results, but without scrutinizing those results, you could miss the researcher intentionally or unintentionally mixing some bias into the presentation of those results to get what they wanted to get out of it.
Thank you so much, Rachel, for that. Let me see. When explaining the conclusion in layman terms, should we state a confidence level?
It's a really good question. It's not required. It can be helpful, but if you present the p-value, then you kind of already have yourself covered. So without going into too much detail, depending on how you've set your alpha, and depending on if you did a one-tailed versus a two-tailed test, knowing the p-value of your test can be just as informative as a confidence interval. The difference primarily being a p-value is only giving you the significance of the test. The confidence interval is telling you the range of values that you're confident contain the true population value. So this, in terms of like a real world application, is much more informative than a p-value, but they should give you the same results either way as far as the significance of the study. Again, depending on if you did one-tailed versus two-tailed.
Thanks, Rachel. A couple more questions. Is SAS available?
It's not something that's offered by NCU. I believe SAS is a paid program like SPSS is. So if you wanted to use SAS, you could, but you would have to pay for your own subscription. I mean, you could always reach out to either, I don't know, the CTL or the service desk to see if they could do an exception or something like that. I just know that they make SPSS available to students. We have an institution subscription or whatever for that. But SAS, we do not have as a statistical package that we have available for students.
Yeah, I'm not familiar of having that as a package for students through the CTL either. Couple more here, and I think we've got about 5 more minutes left, so we have a little bit of time. Can you speak to how logical positivism is the basis for statistical studies?
I have no idea.
Okay, that's okay.
I don't know what logical positivism is.
Okay. Oh goodness. Timothy, if you want to expand, you're welcome to. I'm sorry, I struggled with that one. Where do you find the G-Power tool?
So you can find it on the Academic Success Center website. We have a link to it. There's some college over in Germany that has this available. So let me move this stuff around here. So if you go to the Academic Success Center website, go to our statistics resources, go to Statistics Basics, scroll down. There's a link here for G-Power 3. And this will take you to their homepage. And then once you're here, you can scroll down and there's the download section here. So you can download it for Windows or Mac. They have the manual. I think it's farther up. Yeah, right here is the G-Power manual, tutorial, G-Power. So there's a few resources here as well. But that is free for students or anybody through their website here. University of Dusseldorf.
Awesome. Thank you so much, Rachel. And while we have just a few moments left, can you kind of explain a little bit from the Academic Success Center how students can reach out to you for coaching? Can you explain just a tad bit, like a minute, on how that works?
Sure. So if you're on our homepage, we have this section right here in the middle. It says Ask a Coach. You can click here to chat with us. Over on the left, you'll see we have our chat hours listed, and you can also start a chat from over here. It looks like here is a message, and it says that it's not on duty. So if I was trying to start a chat right now, I couldn't, because we don't have a chat coach that's currently available in chat, but you can send a text message. So this number here is for texting only. If you call it, it'll like ring or whatever, but nobody ever answers. We don't have like a voicemail, like it's literally only for text messaging.
Okay.
But you can send a text message, or you can submit a ticket using this Ask a Coach option,
Okay.
or you can send it via email. And those same options are right up here as well. So you can chat with us, submit a ticket, email us, or text us.
Awesome. Great. And then do you have kind of, you mentioned you have set up times where you come in and you have, I think it's called power hours potentially. Is that right?
Yeah.
Is there anything set up for you guys? Can you explain how that works?
So the power hours are like the academic support team. So the Academic Success Center, the library, the CTL, we all host these power hours throughout the week. And the idea behind them, kind of creating like a virtual study session space for students.
Great.
So the way that I see this as an online student, one of the biggest struggles is setting aside time to do your reading, to do your assignments, things like that. You don't have a class that you have to report to at a certain time on specific days, things like that. Like the responsibility of getting your work done relies solely on your shoulders. And so these power hours I see as an opportunity to block out that time in your schedule and say, okay, during these 2 hours, I'm going to work on this course. I'm going to do this reading. I'm going to start this assignment. So setting up some of those goals for yourself and using that as blocked time. So that way, if you have, kids or a spouse or, other responsibilities, you can treat that as like a course, like I'm going to class during this time. So I'm unavailable. So it helps you to be more accountable. The other perk is that these are all hosted by different staff with different expertise. So attending these sessions allows you to get some live support. So like if you attend on Mondays or Fridays, you would connect with me. With me on Fridays is a writing coach as well. So I'm there. I can answer statistics questions, APA style questions, any questions about the Academic Success Center, some writing questions. On Fridays, Brian can help by answering questions about writing and APA style and stuff as well.
Great.
But it's just a really great opportunity to have that accountability space, but also be able to use that to connect with some of the staff to be able to ask questions and stuff as well.
Absolutely. Rachel, thank you so much for walking through that, because we do often get questions about them from the CTL. And I thought, hey, it would be great to ask you that as we close here today. So I want to thank all of the participants. Just great job asking questions. And just so you know, Rachel, several people on the chat have mentioned truly informative. They very much so appreciate your time and expertise. And I will echo those sentiments. And thank you, everybody, for being here. Until the next time.
Yes. Thank you guys for joining.
Bye-bye.